Alright, so 2.3 part 4, we are still working on taking derivatives with the quotient rule. So on this first problem here, we're trying to find f prime of 2. That means to find the slope when x is 2. So we can go ahead and use the quotient rule on this. So we're going to say f prime of x is equal to, what's the derivative of the numerator? Hannah, what is it? Take the derivative of this. Right. So we're going to have 3 minus 2x. That's the derivative of the top. Times g minus the numerator. And then the derivative of g is just going to be what? 1, right? And then it's all over g squared. Now, normally we would have to simplify this. We'd have to multiply it out, multiply the negative, clean it up. But if we're just going to plug in 2, it's really not necessary. All we have to do is just plug in 2 now. Anywhere we see an x, we're going to plug in the number 2. See what I did? 3 minus 2, plug in 2 there, plug in 2. Everywhere I saw the x, I plugged in a 2. So now, right here, should I do 3 minus 2 first or 2 times 2 first? 2 times 2. Follow your order of operations. So I'm going to have 3 minus 4. That's going to be negative 1 times 2 minus, again, multiply first, 6 minus 4 is 2 all over 4. So this is going to give me negative 2 minus 2 over 4. And negative 4 over 4, f prime of 2 is going to be negative 1. On a problem where I'm trying to find the slope at a specific point, that's going to be something that I could check on my calculator. I can check it by going to y equals. I can put this in by doing 3x minus x squared all over x. And then I quickly do zoom 6 to graph it. And then we want to know what's the slope at 2. So once I have this, I can do my second trace, calculate dy dx at x equals 2, and it tells me that the slope is negative 1. Can anybody think of why this function just ended up being a line like that, a slanted line? Yeah, if you factored the x out of the numerator, you would just get 3 minus x. So that's really just the function. Remember way back when at the beginning, if we simplify this by dividing this by x and this by x, this function is 3 minus x. That's what we're really graphing, but there's a hole in the graph at 0. Remember all of that? So there's a hole in the graph at 0. But this function, what's the slope of this function always? Negative 1. So see how we could have gotten it by doing it that way too? All right, just kind of putting that together. All right, let's look at example 5. We're trying to find the slope at pi over 6 for this function. So I'm going to go f prime equals, we're going to do the derivative of the top. So what's the derivative of cosine x? Good, negative sine x times the denominator minus the numerator, and then the derivative of g is just going to be 1 all over g squared. So on this one, I have to plug in pi over 6 now. So f prime of pi over 6, that's going to mean the slope at pi over 6. What's the sine of pi over 6? 1/2. So it says to make it negative, so it's going to be negative 1/2 times x, which is pi over 6, minus, and then what's the cosine of pi over 6? Good. All over x squared. So I have to square pi over 6. Well, if I have to square pi over 6, I have to square the top and square the bottom. So that's going to be pi squared over 36. Now, how do we simplify that? Well, I have negative pi over 12 minus radical 3 over 2 all over pi squared over 36. That's what I've got right now. Does anyone know how we can simplify that? What do? Multiply the whole thing through by common denominator, which would be what? For 36, 2, and 12, what should we multiply by? What's the common denominator for 12, 2, and 36? 36, right? So I'm going to multiply by 36 in the numerator and 36 in the denominator. The reason I'm allowed to do that is because what's 36 divided by 36? 1. I don't change the value if I multiply by 1. So now I'm going to distribute this through here, and I'm going to multiply it through here. So if I have 36 divided by 12, that's going to give me 3. So I'm going to have negative 3 pi minus, and then 36 divided by 2 is 18. So that's going to be 18 radical 3 all over. These are going to cancel, and so then I'm going to get pi squared. And that would be our answer. You want me to go back through that again? What's confusing to you? Some of you look confused on parts of it. So this would be our answer. So watch again how I can check this. I can do negative 3 pi minus 18 radical 3. I can get that answer. Divide that answer by pi squared. So here's the approximate answer for this. Negative 3.477. Okay, now this one's kind of hard to check. I don't know if you'd want to take the time to check it, but you know, if you've got the time and you're taking a quiz or something and you finish early, you know, you could go back and check these definite derivatives when we're trying to find the exact slope. So on this one, I'd want to do a zoom trig because it's a trig function, and I want to know what's that slope at pi over 6. Well, the first thing I'm going to look at is that this is a negative slope. Pi over 6 would be, I don't know, right around in here somewhere. That does look like it'd be a negative slope. I'm going to do second trace calculate dy dx at pi over 6, and it tells me that that slope is negative 4.11. Is that what I'm plugging in? Pi over 6? What happened? Oh, I forgot my 3 up there. That's what happened. So it was negative 3 pi minus 18 radical 3, and then divided by pi squared. See, well, I just typed it in wrong though. We had the right answer. See how it is the same? So that is the exact answer. This would just be the approximate answer. So you should not give that answer. That's just approximate, and that's exact. Okay, but see how you can check it. All right, let's look at example 6 now. This is kind of complicated the way this is set up, so I might want to write all of this out. I think I'm going to on this one. So I'm going to have to do f prime, and I'm going to rewrite this as x to the 1/3. So what's f prime going to be? What's the derivative of x to the 1/3? 1/3 x to the negative 2/3. Good. So there's my f prime. And then what's our g prime going to be, just for when we use that later? 2x. So we're just going to jot those down just so we have them when we need them. So now when I go to do the derivative of the whole thing, I have to do f prime times g minus f, and then g prime. all over g squared. This is one of those problems like I was talking about, where the first step on the calculus, that's the only thing that's calculus right there, is using f prime g minus f g prime. The rest of it's algebra. But this is some complicated algebra. Who knows what we could do here to simplify this? It's not simplified at all right now because we have a complex fraction. Any ideas? Okay, let me show you what I can do. I can rewrite this as, get some room right here, x squared minus 1 over 3x to the 2/3 minus 2x to the 4/3 all over x squared minus 1 squared. Let me show you why that would be okay. Do you see how right here with this term, see, here's what people think they can do. They think they can take this x to the negative 2/3 down to the bottom and make it positive. But see, there's subtraction here. If this had all just been multiplication, if this had been times, we could do that. But if this is addition or subtraction, we're not allowed to move this to the denominator. This is only in the denominator within this term. So see how within this term, it's in the denominator, but it's not in the denominator of the whole thing, okay? So now if I have a problem like this, a complex fraction, what's the common denominator for this term, and this term? There's only one, so what's it going to be? That's what I'm going to multiply by. So I'm going to multiply by 3x to the 2/3 on top and 3x to the 2/3 on bottom. So this is a term, this is a term, this is a term, like I said. So when I distribute this through, if I have this over this, what's going to happen? What's this term just going to turn into? Right, so I'm going to have x squared minus 1 minus, what about when I multiply these two? 6x squared, good. Do you guys see why that's 6x squared? Let me pause for a minute on that. Here's why. 3 times 2 is 6. We're multiplying x to the 2/3 times x to the 4/3. What do you do when your bases are alike? What do you do with the exponents? Add them. What's 2/3 plus 4/3? 6/3. What's 6/3 reduced to? 2. Do you now see why it would be that? All right. And then on the bottom, all I have is 3x to the 2/3 times x squared minus 1 squared. And this is okay to have because I don't have a complex fraction anymore and I don't have to worry about rationalizing. We don't care if we have irrationals down here. So now just finish, if we have radicals in the denominator, it's okay. So let's finish this. What's 1x squared minus 6x squared going to be? So we're going to have negative 5x squared minus 1 over, and I could even write this as 3, let me write it up here, negative 5x squared minus 1 over, and it's going to be 3 times the cube root of x squared minus 1 squared. And you could leave it, you could leave this as x to the 2/3 if you wanted, but I want you to understand why that is the cube root of x squared in case it was multiple choice. Would you understand why it is that? Okay. All right, so let's get rid of that. Any questions? All right, good job. So you're going to have some pretty tough problems like that to do on your homework.